Hello everyone, this is Ryan from High Desert Math Tutor, and today I'm going to show you how to work percentage problems. So anytime you're working on a problem that has percentages involved, there are a couple things you need to know. So first thing, when you're given a percentage in a problem, such as what is 20% of 300, you're given 20%, and you're given that in percent form. So the first thing you have to do before you use a percentage in a calculation, you have to convert that percentage into decimal form. Okay, so now that we have that down, there are two ways to convert from percentage form into decimal form. So when you're converting a percentage into a decimal form, there is a fast way and the actual way of doing it. So the actual thing that you have to do, say you had 20%. To convert this into decimal form, you need to divide it by 100%. When you divide it by 100%, these percent signs go away. And then you divide 20 by 100, and what you get is 20 divided by 100. Well, 100 goes into 2 0 times. 100 goes into 20 0 times. So now we add a decimal, and that allows us to add a 0 down here. And 100 goes into 200 2 times. So 2 times 100 is 200. We subtract that, and we have a remainder of 0. So 20 divided by 100 is the same as 0.2. So anytime you're converting a percent into decimal form, you divide it by 100%. But there's a faster way to do this. So the fast way this is always an option because we always divide by 100 when we're converting from percent to decimal form. So if you start with 20%, let's make the observation that 20% is the same as 20.0%. And think about it. If you have $20, you can write that like this. So $20. But if you have a $20 bill, how much change do you have? Well, that's the same as 20.00. So at any given time, you're allowed to add a 0.00 and however many zeros you want, as long as you put the decimal. So the fast way of converting a percent into decimal form is you add the decimal right here, and then you move that decimal 2 places to the left. And what that gives you is 0.2, which is the same as what we got before. So anytime you're given a percentage in a problem, before you can use that in a calculation, you have to convert it to decimal form. The actual way of converting a percent into decimal form is dividing that percentage by 100%. But the fast way of converting the percentage into decimal form is to add a decimal, then move it 2 places to the left. Now, whenever you're solving a problem for a percentage, where say, there are 50 seats on a bus and 30 of them are filled. Well, if you want to know what percentage of the bus is full or occupied, when you do the calculation, you're going to get a percentage that's in decimal form, because anytime you do a calculation with a percentage, that percentage is going to be in decimal form. So going the opposite direction, going from decimal form to percentage, the actual way to convert this, say we had 45% in decimal form, that'd be 0.45. So we convert this back to percent form by doing the opposite of what we did before. So the opposite of dividing is multiplying. So instead of dividing by 100%, we're going to multiply by 100%. Now, just so you see the work, if we take 100 times 0.45, 5 times 0 is 0, 5 times 0 is 0, 5 times 1 is 5. We have to put a placeholder. We can't put a number under that 5 now. 4 times 0 is 0. 4 times 0 again is 0. 4 times 1 is 4. So now we have to put 2 placeholders because we cannot go under that 4. And then notice that anything times 0 is 0. So 0 times 0 is 0. 0 times 0 is 0. 0 times 1 is 0. Now that we're done with the multiplication, we can add these numbers. We have 0 plus 0 plus 0 is 0. 0 again. 5 plus 0 is 5. And 4 plus 0 is 4. So now here is the tricky part. When we have multiplication that involves numbers with a decimal, the way we deal with this decimal is we move it all the way to the right, and we count the number of places we had to move it. So here we had to move it to the right 2 places. So in our final answer, we're going to move it back to the left 2 places. And here we can see that 45% from decimal form, when it's back in percent form, that's the same as 45 with that percent sign. So that was the actual way of converting from decimal form back to percent form. But just like before, there is a fast way of doing this because the procedure is always the same. So all we need to do is take our 0.45, and before we had moved the decimal 2 places to the left. Now to go from decimal form to percent form, we move this decimal 2 places to the right. And what that gives us, I'll do it this way. That gives us 45, and then we add the percent sign. So this is one of the most common mistakes people make, especially on the ASVAB when they're working percentage problems. They forget to convert the percent into decimal form before using it in a calculation. But then you also find yourselves, or many people find themselves, wasting a lot of time during the test trying to multiply by 100 and divide by 100, where the fast way is always just to move the decimal either 2 places to the left or move it 2 places to the right, and you're done. You just have to remember which way to go. Now, this next bit of information is extremely important because you really cannot work on a percentage problem unless you know the formulas or the relationships that percentages involve. So, for percentages, 2 common formulas. These formulas are exactly the same. The only difference is the wording that will maybe fit better with certain problems. So in general, if you have a problem with percentages and just numbers, you can use the formula percent times whole equals part. So here, say if we go back to our bus example, say there were 60 seats on a bus. Well, 60 would be the whole number of seats on the bus. And say that 30 of those seats were filled, we'd put the part that's full under part, which is 30. And here we do not know the percentage quite yet, so we could just put P for percent, and we could solve this using a little bit of algebra for the percentage. So that's the idea of how we use this formula. But if we go to, say, a mall or a store and notice that there's a sale going on where everything is 25% off, that means you're actually paying only 75%. And in a situation like that, once again, this formula will be the same, but it's going to have different words that maybe make more sense for a situation like when you're buying something that's on sale. So a second formula would be percent times the original price is equal to the new price. So just one thing to be aware of with this second formula. If you're looking at something that's on sale, that is 25% off, you put in the original price and you don't put 25% for a percent. No, you need to put the percent that you're going to pay. So if something is 25% off, you're only paying 75%. So you plug in the percent that you are actually paying, and that gives you the new price you have to pay. So just a couple things to be aware of. Now, I have 3 different types of problems that I've put together for you. I'm only going to go over one of each of them. But the 3 things that you might need to solve for if you're solving a percentage problem, you may be asked to find the percent. You may be asked if you know the percent and you know the part that is that percentage of an original number, you may be asked to find the whole number or the original number. Or the most easy situation is, say I asked you, what's 15% of 30? Well, there, we're given the percent, we're given the whole number 30, and we simply multiply those together to find the part that's 15%. So those 3 situations can arise, and here we'll look at them very quickly. So what is 75% of 280? Since this is a percent problem, I'm going to start by writing down a formula that has to do with percentages. So let's write down percent times whole equals part. Now the question is, what do we need to do with the percent before we plug it into this formula? Remember, we need to take 75% and we need to convert that into decimal form. So we can always add a decimal and a 0 on the right side of the decimal. So 75% is the same as 75.0%. Now we can move this decimal 2 places to the left. So the decimal form of 75% is 0.75. Okay, here, let me actually move this, make a little space for ourselves. So put that over here. Now we plug in our 0.75. Now what is the whole that we're dealing with? The whole is 280. So we're going to multiply 0.75 by 280. And our answer is going to give us the part. So I'll do the scratch work over to the right. 280 times 0.75. Well, 5 times 0 is 0. 5 times 8 is 40. So put the 4 up top and the 0 down low. 5 times 2 is 10, but we have to add the 4. So 10 plus 4 is 14. We're done with this 5, so we cross that off and put a placeholder underneath it. Now 7 times 0 is 0. 7 times 8 is 56. So put the 5 up top, the 6 below. Now 7 times 2 is 14, but we still need to add this 5. So 14 plus 5 is 19. When we add, 0 plus 0 is 0. 4 plus 6 is 10, so put a 1 up top, the 0 right here. Now 9 plus 1 is 11. So 1 up here, 1 down below, and 1 plus 1 is 2. But this is not our final answer, because remember, we need to deal with this decimal. So we move this decimal all the way to the right, count how many places we had to move it. We moved it 2 places. And in our final answer, we're going to move it 2 places back to the left. So 75% of 280, that part is 210. Now, anytime you do percentage problems, you want to stop for a moment and ask yourself, does this make sense? So the idea when you're working with percentages is you're taking something and breaking it into 100 pieces. Like percent literally means per is for every, and cent means 100. So for every 100 pieces, if we have 75%, for every 100 pieces, we're taking 75 of those pieces. So in this case, we're taking most of the pieces. Now, to just do a quick check, if we may have gotten the correct answer or if we may have made a mistake, we can look at our calculation and look at this right here. Would you say 210 is most of 280? If the answer is yes, then it looks like we probably did get the right calculation. So, moving on. There are 2 more situations that we can come across, and we'll walk through them together. So let's look at number 8. What percent of 320 is 48? So this is a percent problem, so we can start this problem out by writing down a formula for percentages. So we'll start with percent times whole equals part. Here, we're being asked, what is the percent? We don't know the percent, but we see that it's a percent of 320, which means that 320 is the whole number. And since we do not know percent, we just put a P there, but notice that the final answer is 48, so the part is 48. Now, here's where we need a little algebra. So to get the decimal form of percent, we have to get P by itself. But we're currently multiplying P by 320. So if we want to get P by itself, we need to do the opposite of multiplying by 320. So we'll divide by 320 so that those cancel out. But if we divide one side of the equation by 320, we have to divide the other side by 320 also. So what we get is P is equal to. Now we'll do a little calculation. Just a reminder, right here, we can read this 2 different ways. We can read it as 48 over 320, or we can read it as 48 divided by 320. That being said, we always put the number we're dividing inside the division bar, and the number we're dividing by outside the division bar. So now, how many times does 320 go into 4? And the answer is 0 times. How many times does 320 go into 48? Again, the answer is 0 times. So now we have to add a decimal and bring it up. and we can add a 0. How many times does 320 go into 480? The answer is 1 time. So 320 times 1 is 320. So we'll subtract that. And 0 minus 0 is 0. 8 minus 2 is 6. And 4 minus 3 is 1. Well, we still have a remainder, so we should add another 0. Since we've already added our decimal, we're done adding decimals. So we can bring this 0 down. Now our question is, how many times does 320 go into 1,600? So let's do a little work. 320 times 1 is 320. 320 times 2. 320 times 2. 2 times 0 is 0. 2 times 2 is 4. 2 times 3 is 6. So 320 times 2 is 640. We're not quite there yet. We're not up to 1,600 yet. So let's do 320 times 3. 320 times 3. 3 times 0 is 0. 3 times 2 is 6. 3 times 3 is 9. So 320 times 3 is 960. We're not up to 1,600 yet, so let's keep going. 320 times 4. 320 times 4. 4 times 0 is 0. 4 times 2 is 8. And 4 times 3 is 12. So we get 1,280. Still not at 1,600, so one more time, hopefully. So 320 times 5. 320 times 5. 5 times 0 is 0. 5 times 2 is 10. So 1, 0. 5 times 3 is 15, but we have to add this 1. So 15 plus 1 is 16. So just like that, we got that 320 times 5 is 1,600. So we put this 5 up here, and 5 times 320 is 1,600. So we're going to subtract 1,600. And finally, we get a remainder of 0. So we see that the percent in decimal form is 0.15. Now remember, this is in decimal form because we just got this number from doing a calculation. So the fast way of converting this back to a percent or percent form is to move the decimal 2 places to the right. So 15% in decimal form, 0.15, in percent form is 15%. So now, quickly, the very last situation you'll typically see for percent problems. Just review. The first two is, what is 75% of some number? The second question, what percent do you have if you have 48 out of 320? Now, the last question is 8% of what number happens to be 7.52. So once again, this is a problem that has percentages involved. So let's write down a formula for percent. So percent times whole is equal to the part. Now we're given 8%, so let's convert this from percent form into decimal form. So 8% is the same as 8.0%. So we have to move this decimal 2 places to the left. Notice that means we have to add a 0 here. So this percent in decimal form is 0.08. So we'll plug that in, 0.08 times, now we don't know the whole, so I'm just going to put W for whole. And is 7.52 means it is the part. So the part is 7.52. 2. Okay, once again, we need a little bit of algebra to get the whole by itself. So we're currently multiplying W by 0.08. So the opposite of multiplying by 0.08 is dividing by 0.08. But if we divide one side of the equation, we have to divide the other side. So these cancel each other out. All that's left on the left side is W. But on the right side, we need to do a little division. So remember, this is 7.52 being divided by 0.08. Now, I chose this problem specifically so we could review dividing numbers with decimals. So you cannot divide with a number that has a decimal. So before we divide, we need to move this decimal all the way to the right. But if we move this decimal to the right, we have to move the other decimal to the right the same number of places. So this problem now is actually the same as 8 is dividing 752. So now we ask, how many times does 8 go into 7? The answer is 0 times. How many times does 8 go into 75? Well, I know that 8 times 8 is 64. So 8 times 8 is 64. So what is 8 times 9? Well, 8 times 9 is 72. So 8 goes into 75 9 times, and we get 72. Now 5 minus 2 is 3. We bring down this 2, and we ask, how many times does 8 go into 32? The answer is 4 times. So 8 times 4 is 32. So we subtract that, and we see the remainder is 0. So finally, we see that the number that 8% of it is 7.52, that number is 94. So our answer is 94. So once again, my name is Ryan Kinchin. If you have any questions about percentage problems for ASVAB or any other math, feel free to leave a comment below and tell me about the problem you need help with. If you like this video, please like the video and subscribe, and I'll see you again soon.